Hello, my students. Welcome back into my channel. In this video, I would like to explain how we're solving a past paper. IBDP past paper, Mathematics Analysis and Approaches, Higher Level Paper 1. So this is TC1HL past paper, 30 October 2023. Let's start with number 1. Consider the function f(x) equals x minus 3 and gx x squared plus k squared, where k is a real constant. Write down an expression for decomposition fx, given this composition function decomposition f2 equals 10. Find the possible values of k. Right. So we have to find first this composition function, that g fx equals g fx is this x minus 3, while gx x squared plus k squared. So it becomes x minus 3 squared plus k squared. X squared minus 6x plus 9 plus k squared. Next, b. We're going to find k. Right. If decomposition f2 equals 10, it means 2 squared minus 6x plus 9 plus k squared equals 10. 4 plus 9, 13. Minus, this is times 2 as well. Minus 12 plus k squared equals 10. 1 plus k squared equals 10. So k squared equals 9 because 10 minus 1. K equals square root 9 plus minus 3. Number 2. Events A and B are such that probability A equals 0.65, probability B 0.75, and probability A intersection B equals 0.6. Find probability A union B. So probability A union B, the formula is probability A plus probability B minus probability A intersection B. So it becomes, this is probability A 0.65 plus 0.75, probability B, and the intersection 0.6. So it becomes 0.8 if you calculate. Next, B. Hence, or otherwise, find probability A apostrophe intersection B apostrophe, or probability non-A intersection probability non-B. Okay. Probability non-A intersection non-B, not even A and intersection even B. Non-even A intersection non-even B. But I will sketch first. I will sketch first that the Venn diagram A, B. Firstly, I will shading area of non-A. Non-A, it means this area. Non-A. Okay. After that, area non-B. I'm going to use this color. Non-B, it means this, non-B. Okay. All right. So, which area has double shading? That is area of non-A intersection non-B. So actually, intersection non-A and non-B, same with even A union even B apostrophe or non-A union B. I will sketch that. So the probability. Okay. Now, A union B is this, A union B, or A and B. Okay, the shaded area is area of A union B. So how about non-A union B? I'm going to shading out of A union B, this area. Pay attention for the shaded area. This area of non-A union B. Okay, so how we calculate the probability? Probability non-A intersect non-B equals probability A union B apostrophe or 1 minus probability A union B. So it becomes 1 minus probability A union B is this one, 0.8. That means 1 minus 0.8 equals 0.2. This the answer. Next, number 3. The sum of the first n terms of an arithmetic sequence is given as n equals pn squared minus qn, where p and q are positive constants. It is given that S4 is 40 and S5 equals 65. Find the value of P and the value of Q. Okay. Based on this information that S4 equals 40, so it means this sequence Sn being S4 equals P times 4 squared minus Q times 4 equals 40, or 16p minus 4q equals 40. This is the first equation. And S5 equals 65. So it means x5 equals p times 5 squared minus q times 5 equals 65. So 25p minus 5q equals 65. This is the second equation. From the first equation and second equation, 16p minus 4q equals 40. 25p minus 5q equals 65. We are going to eliminate q. So multiply by 5, multiply by 4. It becomes 80p minus 20q equals 200. It becomes 100p minus 20k. How much is 260? Yeah. Minus, eliminate, minus 20p minus 60. So p equals minus 60 over minus 20 equals 3. So p equals 3. Now we're going to find q. Based on this equation, 16p minus 4q equals 40. So 16 times 3 minus 4q equals 40. 48 minus 4q equals 40. So 4q equals 48 minus 40. 4q equals 8 and q equals 8 over 4 equals 2. B, find the value of U5 or the value of U5. I mean, B, U5 equals S. 5 minus S4. 65 minus 40 equals 25, this. And 4. In the following triangle ABC, AB equals square root 6 centimeters, AC equals 10 centimeters, and cosine BAC equals 1/5. Find the area of triangle, right? The first step, cosine BAC is 1/5. So we have to find sine BAC, right? So it means cosine squared BAC is 1/5 squared equals 1 over 25. A trigonometric equation is sine squared theta plus cosine squared theta equals 1, or sine squared theta equals 1 minus cosine squared theta. So it means sine squared BAC equals 1 minus cosine squared BAC. 1 minus 1 over 25. So it is 24 over 25. So sine BAC equals square root 24 over 25, or square root 24 over 5. So that we're going to find area ABC. Area of ABC is half times AB times AC sine ABC. Yeah, AB, this, and AC, this one. And this is the angle. So it's going to be half times square root 6 times 10 times square root 24 over 5. 10 divided by 2 equals 5, and 5 divided by 5 equals 1. So square root 6 times square root 24. It is square root 144. So it means area ABC is 12 centimeters squared. Nice. The binomial expansions of 1 plus kx power n is given by this expansion. So this expression is expansion of 1 plus kx power n. Find the value of n and k, right? If 1 plus kx power n, based on this information, equivalent, the expansion is 1 plus 12x plus 28 k squared x squared plus so on till k power n x power n. The rule of expansion, according to the rule of expansion, that if we expand this expression, it becomes like this: combination 0 n of kx power 0 plus combination 1 and kx power 1 and then combination 2 and kx squared. So it becomes k squared x squared plus on until plus cn of kx power n. So if you look this information, that we can state that combination 1 and kx, this combination equals this, equals 12x. X eliminate, divided, so becomes combination 1 and k equals 12. So this combination will be like this. I'm going to show you if combination 1 and k, it will be n factorials over 1 factorials times n minus k factorials. N minus 1. Sorry, n minus, because it's 1. The ratio is 1. So, yeah, times k here. So it will be n times n minus 1 factorials over 1 times n minus 1 factorials times k. Divide n minus 1 divided by n minus 1 equals 1. So it becomes nk equals 12. This is equals 12 based on this information. And the second is this one. Combination to n k squared x squared equals this 28k squared. So we can write in here that combination to n k squared x squared equals, wait, at 28 k squared x squared divide becomes 1, so it means combination 2n equals 28. So this combination becomes like this: n factorials over 2 factorials n minus 2 factorials equals 28. So it becomes n times n minus 1 n minus 2 factorials over n minus 2 factorial. 2 times 28 equals 56. Divide n minus 2 divided by n minus 2, so it becomes n times n minus 1, 56. I'm going to move here. So multiply becomes n squared minus n minus 56 equals 0. Factorize n it is minus 8 plus 7. So n equals 8 or n equals minus 7. So this is not the solution because n is not minus 7. So only this one. This is the solution. So the solution n equals 8. If n equals 8, based on this statement that nk equals 12, nk equals 12, so 8 k equals 12, so k equals 12 over, so k equals 12 over 8. Simplify becomes is 1 by 4, 3 half. So n equals 8 and k equals 3 half. Next, number 6. Prove by mathematical induction that 5 power to n minus 2 power 3n is divisible by 17. Is divisible by 17. So we're going to prove by mechanism of mathematical induction. So there are 3 steps of mathematical induction. The first step is if n equals 1, it means this expression becomes 5 power 2 or 5 squared minus 2, 3 minus 1, 2 cube equals, it becomes 25 minus 8 equals 17. So 17 divisible by 17 because multiply by 17. Divisible by 17. So it means we can say on this first step that 5 power 2n minus 2 power 3n is divisible by 17 if n equals 1. The second if n equals k. If n equals k, so 5 power 2n minus 3 power 3n equals 5 power 2k minus 3 power 3k. Okay. Now, if 5 power 2n minus 2 power 3n is divisible by 17, it as well 5 power 2k minus 3 power 2k or minus 3 power 3k is divisible as well. So 5 if 5 power 2n minus 3 power minus 2 power, sorry, minus 2 supposed to be power 3n is divisible by 17. So as well, 5 power 2k minus 2 power 3k is divisible by 17. The third, if n equals k plus 1. If n equals k plus 1, so this expression to 5 power 2n minus 2 power 3n becomes 5 power 2 times k plus 1 minus 2 power 3 times k plus 1. So becomes 5 power 2k plus 2 minus 2 power 3k plus 3. So it becomes 5 power 2k times 25 because 5 squared minus 2 power 3k times 8. So we can state like this, 25 times 5 power 2k minus 2 minus 8, 8 power 8 times 2 power 3k. And I will set like this. This is 17. 5 power 2k plus 8, 5 power 2k minus 8 times 2 power 3k. Okay. And it is going to be like this. 17 power times 5 power 2k plus 8 times 5 power 2k minus 2 power 3k. This. Now, look this statement that 5 power 2k minus 2 power 3k is divisible by 17. So this is divisible by 17, this expression. Divisible by 17. As well, this 17 divisible by 17. So we can state that 5 power 2n minus 2 power 3n is divisible by 17 because 1, this expression true for n equals 1, that 5 power 2n minus 2 power 3n is divisible by 17. The second, it is true for n minus n equals k, that 5 power 2n minus 2 power 3n is divisible by 17. And the third, true for n equals k plus 1. This, that 5 power 2n minus 2 power 3n is divisible by 17. Number 7, it is given that z equals 5 plus qi satisfies the equation z squared plus iz equals minus p plus 25i. Find value p and q. All right. I will substitute z into this equation. So that's equation z squared plus iz equals minus p plus 25i becomes 5 plus qi plus I times 5 plus qi. This is squared cos minus p plus 25i becomes 25 plus 10qi. And then this is I squared is minus q squared, and then plus 5i minus q, because I times I equals minus 1, minus p plus 25i becomes, I will separate first real and imaginary. So 25 minus q squared minus q plus 10q plus 5i minus p plus 25i. So it becomes 10q plus 5 equals 25. So 10q equals 20, q equals 20 over 10 equals 2. Next, 25 minus q squared minus q equals minus p. Q equals 2, so it becomes 25 minus 4 minus 2 minus p, so 16 equals minus p. P equals minus 16. Yeah, so q equals 2. Next one, find integral. Right. Through integration by parts, that u equals ln, ln x squared. So du equals ln x squared. It means 2 ln x times 1 over x. So it becomes, the x becomes 2 ln x over x. This is du dx. dv equals x dx. And then phi equals integral x dx. So it becomes half x squared plus c, or x squared half plus c. Right. Based on this information, it means integral x ln x squared dx equals u times phi. Yeah, it means ln x squared half plus c minus integral half x squared times 2 ln x over x dx. It becomes half x squared ln x squared plus c minus it is divided and x, so integral x ln x dx. Now I will using the second substitution for this integral. If u equals ln x, so du dx equals 1 over x. So dv equals x dx, p equals integral x dx, phi equals half x squared plus c. So this integral being half x squared ln x squared, plus c minus it is ln x times half x squared minus integral half x squared times 1 over x dx. It becomes half x squared ln x squared plus c minus ln x, half here ln x times x squared plus integral, half in front, half integral x dx. It's going to be half x squared ln x squared minus half x squared ln x plus half times 1 over 4, because half times half x squared plus c. Okay, this is the integral. Next, show that integral 1 to 4 x ln x squared dx equals this expression 32 ln 2 squared minus 16 ln 2 plus 15 over 4. Okay. B, integral 1 to 4 of x ln x squared dx. Just substitute 4 and 1 into this expression. So it becomes half times 4 squared ln 4 squared minus half times 4 squared ln 4 plus 1 over 4 times 4 squared minus, after 4, 1. Half times 1 squared ln 1 squared minus half times 1 squared, then 1 plus 1 over 4 times 1 squared. It is 16 over 2 8 ln 2 squared minus half times 16 ln 2 squared plus 4 minus this is 0 because ln 1 equals 0. So 0 plus 1 over 4 becomes 8. 8 times 2 ln 2 squared minus 8 ln, or 8 times 2 becomes 16 here. Wait, I'm going to change 16. Or 8 times 2 ln 2 first, yeah, plus 4 minus 1 over 4. Okay, this definite integral. So it's going to be 8 times 4 ln 2 squared minus 16 ln 2 plus 4 minus 1/4, 3/4 becomes 32 ln 2 squared minus 16 ln 2 plus 4 times 3, 12 plus 3, 15. 15 over 4. Yeah, this is the answer. Now this. Number 9, consider the function fx sine squared kx over x squared. Show that f is an even function. Okay, even function happening, even function happening if f minus x equals fx. So we are going to prove that if f minus x equals fx, right? Fx is sine squared kx over x squared. So f minus x, if the variable being minus x, it becomes sine squared minus kx over minus x squared. So it becomes, I will write it like this, minus sine kx squared over minus x squared is x squared. Okay, so if minus squared being positive, being sine kx over x squared equals fx. Prove that f minus x equals fx. So fx is an even function. Next, b. b limit fx equals 16, xx approach to 0, right? Limit x approach to 0, fx, it means limit sine squared kx over x squared equals 16. It says that 16. Now, I'm going to do this to find the differential of numerator and denominator based on the L'Hopital rule. Okay, based on the L'Hopital rule. The L'Hopital rule says that we are going to find the differentiations of numerator and denominator, right? So, differentiation or differentiate of sine squared kx if y equals sine squared kx, the derivative of y is 2k sine kx cosine kx. So I'm going to write down here 2k sine kx cosine kx over 2x, because derivative of x squared is 2x. And after that, based on the identity trigonometry, that if 2 sine x cosine x equals sine 2x. Okay. So if 2k sine kx cosine kx, it is equals k sine 2kx. Yeah. So this numerator I will writing like this. It becomes k sine 2kx over 2x equals 16 equals 16. And after that, it's going to be, yeah, find the derivative as well. Derivative. The second derivative, the first derivative is, yeah, this step. After that, the second derivative on this step. The second derivative of sine 2kx. This based on L'Hopital rule. It is cosine 2kx times 2k. The chain based on chain rule, this, or 2k cosine 2kx. So limit x approach to 0. The derivative of this one is this one, 2k cosine 2kx over 2 equals 16. Now substitute 0. becomes 2k cosine 0 over 2 equals 16. Cosine 0 is 1, so 2k times 1 equals 2k over 2 for 16. And yeah, 2k, it means k equals 16 because 2 divided by 2 equals 1. Wait, 2k supposed to be this. Oh, there is k here, it means 2k squared here. Okay, k squared. So k equals square root 16 cos 4. Number 10, the functions f and g are defined by fx, this, ln 2x minus 9, where x greater than 9 over 2, this gx. State the equation of the, oh yeah, vertical. We are going to state the vertical asymptote. Y equals gx. Okay, and what's next? B, the graphs y equals fx and y equals gx intersect at two distinct points. Okay, so that at the points of intersection, okay, this equation, and show that d squared minus 9d greater than 0. Find the range. We are going to find range. Okay. Firstly, this one. A, y equals 2 ln x minus ln d. Okay. Now, I'm going to find the intersection with x-axis and y-axis. Intersection with x-axis happening when y equals 0. When y equals 0, it means this equation being 2 ln x minus ln d equals 0. So 2 ln x equals ln d, or ln x equals a half ln d, or ln x equals ln d or half, or x equals square root d. So it has a point on x-axis at square root d, comma 0. Now, how about if x equals 0? When x equals 0, this equation being y equals 2 ln 0 minus ln d. As you know that ln 0 equals infinite, so it is infinite. So infinite means the vertical asymptote. So the vertical asymptote happening when x equals 0. Next, B. show that at the points of intersection, x squared minus 2dx plus 9d equals 0. Right. Intersections, if intersection happening when fx equals gx, y equals y. So ln 2x minus 9 should be equals to ln x minus ln d, or it is ln x squared minus ln d, or it is ln x squared over d, ln 2x minus 9. Right, so it means I'm gonna move here 2x minus 9 equals x squared over d. Now multiply by d becomes 2dx minus 9d equals x squared, or we get the equation x squared minus 2dx plus 9d equals 0. This is the equation. This is 1. Okay, double I. Show that d squared minus 9d greater than 0. Greater than 0 if d greater than 0, as you know that d equals b squared minus 4ac. Okay, so it means b squared minus 4ac is greater than 0. So from this equation, we got that a equals 1, b equals minus 2d, and c equals 9d. So substitute that information into this inequality, we got 4d squared minus 36d greater than 0. After that, divided by 4, and it becomes d minus 9d greater than 0. This. This. Oh, wait. Now, yeah, with space, add space. 3. 3. Find the rings. Okay, rings of D. Based on this information that D squared minus 9D greater than 0. So D, factorize D times D minus 9 greater than 0. Through number line, I'm going to create a number line here. 0, 9. The solution area are here and here. So this area is area of x less than 0, and this area is area of x greater than 0. So the rings are x less than 0 and x greater than 0. Now, continue question. The following diagram shows part of the graph of y equals fx and y equals gx. So this is the graph of fx, okay, and this graph of gx, right? The graph intersect at x equals p and x equals q here and here. So there are two intersect points. In the case where d equals 10, right, this important information, find the value of q minus p. We are going to find q minus p. Express your answer in the form a squared b, right? Yeah, d equals 10. From part B, we have an equation that x squared minus 2dx plus 9d equals 0. This equation, I mean, this equation. So, from this equation, we can substitute d equals this equation, x squared 20x plus 90 equals 0. So a equals 1, b equals minus 20, c equals 90. So x1 and x2 we got from the formula becomes 20 plus minus square root. 20 squared is 400 minus 4 times 1 times 90 over 2 times 1. So it's going to be 20 plus minus square root 400 minus 360 for 2, and it's going to be 20 plus minus square root 40 over 2. So after that, it's going to be 20 plus minus square root 4 and 10. This, yeah, 10 times square root 4 times 2 over 2. So it's going to be 20 divided by 2 equals 10. 2 divided by 2 equals 1. So it plus minus square root 10. So it means x1 or q equals 10 plus square root 10, x2 equals p 10 minus square root 10. So q minus p equals 10 plus square root 10 minus minus 10 minus square root 10, 0, and it becomes square root 10 plus square root 10. It is 2 square root 10. That's the solution. 11. Consider the function fx equals e power cos 2x. E power cosine 2x. Right. And you can look the questions A, B, C, D, until, wait, Yeah, A, B, C, D, E. Right. We're going to doing one by one. A first. A, find the coordinates of the points on the curve y equals fx, where the gradient is 0. Well, if gradient 0, it means dy dx equals 0, or the derivative equal 0. So, wait, I'm going to do, so fx equals, which fx e cosine 2x. And the interval between, yeah, x between minus pi 4 and 5 pi 4. Yeah, the interval minus pi 4 and 5 pi 4. Okay, gradient equals 0. It means the derivative of fx equals 0. So derivative, I'm going to using that the product rule. If u equals cosine 2x du dx derivative minus 2 sine 2x. If y equals e power u, cosine 2x is u, so dy dx equals e power u. So the derivative, according to the product rule, that the fx over the u times du over the x. The fx over du is this one, e power u, e power cosine 2x times du dx is this one, minus 2 sine 2x. So it will be minus 2 sine 2x times e cosine 2x. Yeah. Plus equals 0. Okay. So there are two possibility that minus 2 sine 2x equals 0, or e power cosine 2x equals 0. But for this one, there is no solution for this part. The solution we got on this part, minus a sine 2x equals 0, because 0 over minus 2. So 2x equals sine 0 is 0, so 0 sine pi as well equals 0, and sine 2 pi. Right, so x 0 divided by 2 equals 0, pi over 2, 2 pi over 2 is pi. Yeah. So this is the solution. Now, If x equals 0, we're going to find a coordinate point. So fx will be e power cosine 2 times 0. Cosine 0 is 1, so e power 1. So the coordinate point the coordinate point 0 and e, 0, comma e. If x equals pi half, fx will be e power cosine 2 times pi half. It is e power minus 1 because cosine pi is minus 1. 1 over e, and the coordinate point pi half, comma 1 over e. If x equals pi, fx equals e power cosine 2 pi. So it is e power 1 because cosine 2 pi equals 1. So the coordinate point is pi, comma, e. Yeah, so there are 3 coordinate points next. P, question B. Using the second derivative, right, the second derivative at its point found in part A. Okay, so that the curve y equals fx has, yeah, the curve fx has 2 local maximum points and 1 local minimum point. Oh, so it means we are going to prove that it has 2 uh that it has 2 minimum point at 2 maximum point and 1 minimum point. Okay. B, a derivative fx equals minus sine 2x minus 2 sine 2x times e power cosine 2x. So the second derivative will be minus 2 sine 2x. I have to make sure. Using product rule, if u u times phi, it means derivative u phi plus, okay, this product rule. Okay, so minus sine 2x, okay, because cosine 2x times minus 2 sine 2x. Yeah, e power cosine 2x. minus, yeah, should be minus because sine to cosine, right? 4 cosine to x e power cosine to x. Yeah, this. So this, the second derivative is this one. Uh, Now we check one by one. At x equals 0, it becomes minus 2 sine 0 times minus 2 sine 0 e power cosine 0 minus 4 cosine 2 times 0 is 0 e power cosine 0. So it is sine 0 is 0. So for this term is 0 minus cosine 0 is 1. So 4 times or minus, yeah, 4 times e. Yeah, because cosine 0 equals 1 equals minus 4e less than 0. It means it is the maximum point. Right. Now at x equals half pi. So it becomes half, sorry, not 0, but half pi. So minus 2 sine half pi okay. After that, minus 2 half times 2 equals 1. That's 1. Okay. E power uh, cosine cosine 2 pi. Wait, not cosine 2 pi, or 2x. Cosine 2, sine pi, it means minus 4 cosine pi e power cosine pi. So it is 0 because sine pi is 0. So this part is 0 minus 4 times, this is minus 1. 4 times minus 1 e power minus 1. So it becomes minus becomes 4. Yeah. 4 times 1 over e, 4 over e. 4 over e less than 0, it is maximum point. Now, when x equals pi, so it is it becomes 2 pi, yeah, minus 2 sine 2 pi minus sine 2 pi e power cosine 2 pi minus 4 cosine 2 pi e power cosine 2 pi, right? We're gonna find the uh, sine 2 pi. So it is 0. This part is 0. 0 minus 4 times 1 e power 1. So it is minus 4e less than 0. If less than 0, it is maximum. Yeah. Sorry, it's supposed to be this is greater than 0, so minimum. It is yeah, greater than 0, I mean. So it is minimum. So prove that there are 2 maximum and 1 minimum. See, sketch the curve y equals fx, taking into consideration the relative values of the second derivative found in part B. Oh, so we are going to sketch using this result, 0, half pi, and as well pi. See, y equals e power cosine 2x, which x interval from 0 to pi. So when x equals 0, this function becomes y equals e power cosine 0 or e power 1 e. So the coordinate point 0, e. When x equals pi half, y equals e power cosine pi half. Cosine 2 pi half. It means 2 here. So e power cosine pi. It is e power minus 1. So the coordinate point is pi half comma 1 over e. When x equals pi, y equals e power cosine 2 pi, or e power 1 cosine 2 pi equals 1. So the coordinate point pi, comma, e. Now let's sketch. This is x-axis, y-axis. This is e, and this one 1 over e. Okay, this axis for y in e. This is x-axis in term pi. Pi half pi. Okay, so and this the coordinate point. Okay, okay, like this. The graph. Okay, now D. Question D is about what? Find the Maclaurin series for cosine to x. Okay, cosine to x first. After that, find the Maclaurin series for e cosine to x minus 1. In term x power 4 as well as x power 4. And third Maclaurin series for fx as well in x power 4. Right. D. The Maclaurin series, I will write down first. F0 plus, yeah, the first derivative, but should be x should be changed become 0. The second derivative over 2 factorials times x squared, and the third derivative, but x equals 0 over 3 factorials times x squared, so on until f n derivative, x should be 0 over n factorials times x power n. Right. Now I'm going to start with fx. X is cosine 2x. So it means f0 is cosine 0, 1. The first derivative of cosine 2x is minus 2 sine 2x. If x equals 0, becomes minus 2 sine 0. It is minus 2 times 0 equals 0. Second derivative becomes minus 4 cosine 2x. Second, the second derivative. This is x 0 minus 4 cosine 0. Cosine 0 equals 1, so it is negative 4. The third derivative, 8 sine 2x. If x equals 0, becomes 8 sine 0. 0. And the fourth derivative equals 16. Yeah. 16 cosine 2x. If x equals 0, being 16 cosine 0 equals 16. Now we create the series. Maclaurin series becomes fx 1, this one, and then plus 0, but if 0 over 1 factorial equals 0. So I'm going to skip to negative 4. So it will be minus negative 4 divided by 2 divided by this 2 factorial equals 2. So it becomes, wait, I'm going, I will writing 0 over 1 factorial x plus minus 4 over 2 factorials x squared plus 0 over 3 factorials x cubed plus 16 over 4 factorial x power 4. Just until x power 4. So it becomes 1. This is 0, 0 as well. So 1 minus 2x cubed plus 16 over 24 x power 4. It becomes 1 minus 2x cubed plus 2/3 x power 4. This is the series, Maclaurin series. One. Okay, next. This is D1I, next double I. Double I, I'm going to using another color. Okay. Right. If e power cosine 2x minus 1, so wait. Okay. It becomes e power 1 minus 2x squared plus 2x power 4 over 3 minus 1. So 0, it becomes e power minus 2x squared plus 2x power 4 over 3. Why becomes e power this series? Because from this one. Yeah. This is cosine 2x minus 1. Fx is cosine to x minus 1. This one. So I'm going to writing like this: e power minus 2x squared times e power 2x power 4 third, like that. After that, I'm gonna explain this. Which one? Now expand. Yeah, this one. I'm going to explain how we expand this. So e power minus 2x squared is 1 minus the expansion becomes 1 minus 2x squared plus 2x power 4. So how about if e power 2x power 4 over 3? It is 1 plus 2/3 x power 4. This is expansion, so is so on. You can expand, but we are going to find until x power 4. So it means e power minus 2x squared times e power 2x power 4 third is multiply of this one, this part, and this part. 1 minus 2x squared plus 2x power 4 times 1 plus 2/3 x power 4, so on. And then times 1 is 1. 1 times 2/3 x power 4 minus 2 times 1 minus 2x squared minus 2 times, oh, it will be x power 6, so no need. No, this one. 2 times 1, 2x power 4. So it becomes 1 minus 2x squared. Now 2/3 plus 2. 2/3 plus 6/3, 8/3 x power 4 plus on. The third, uh, Maclaurin series as well of fx e power cosine to x. So it is e power 1 minus 2x squared plus 2x power 4 third. Sorry, this one I have to make clear. Yeah, this different. So this is e power cosine to x minus 1, different with this one. This is e power cosine 2x without minus 1. Okay, so it's still like this. E power 1 minus 2x squared plus 2x power 4 third. So it becomes e power 1 times e power minus 2x squared times e power 2x power 4 over 3. Right? E power 1 is e, and e power minus 2x squared is 1 minus 2x squared plus 2x power 4, while e power 2x power 4 third equals 1 plus 2 third x power 4. So fx, the series of e power cosine to x is e times this one minus 2x squared plus 2x power 4 times 1 plus 2 third x power 4 plus so on. If multiply becomes e times, just now we calculate already, it's 1 minus 2x squared, a third x power 4. 1 minus 2x squared plus a third x power 4. Right. E integral, let's check first. Integral, okay, 0 to 1 over 10 of fx. Okay, we have to prove that the result is 149e over 1500. Right, 0 to 1 over 10 of fx e power cosine to x dx. So it is 0 to 1 over 10 of e times 1 minus, wait, use the first two non-zero. First two non-zero. Yeah, non-zero. It means 1 n minus, wait, this one, two non-zero. 1 n minus 2x squared. 2x squared dx comes e times 0 to 1 over 10, and the integral is x minus 2 third x cubed. After that, e times 1 over 10 minus 2 third times 1000. It is 0, 0, and 0. So e times 1 over 10 minus 2 over 3000. E times, I'm gonna set like this, times, since becomes 3000 here, it means times 300. 2 over 3000 e times 298 over 3000 and divided by 2, 149 over 1500 e. Yeah, that's the solution. Number 12, find the binomial expansions of cosine theta plus I sine theta power 5. Give your answer in the form a plus bi, where a and b are expressed in the terms of sine theta and cosine theta, right? 5, 12a, we are going to expand cosine theta plus I sine theta power 5. Based on binomial expansion rule, it becomes combination 0 and 5 of cosine power 5 theta plus cosine combination 1, 5 cosine power 4 theta and times I sine theta plus combination 2, 5 cosine cube theta, then I sine theta squared plus cosine combination 3, 5 cosine squared theta, I sine theta cube plus combination 4, 5 cosine power 1 theta, I sine theta power 4 plus cosine 5, 5 combination 5, 5 cosine power 0. So I sine theta power 5. And this combination, this expansion becomes, yeah, this is 1, so cosine power 5 theta, or wait, I'm going to writing the combination first. Combination being like this, wait, I'm gonna start from here. So it becomes 5 factorials over 0 factorials times 5 minus 0 factorial. And it's cosine power 5 theta plus 5 factorials over 1 factorial, 5 minus 1 factorial, cosine power 4 theta, I sine theta plus combination 2 and 5 and 2 with so it becomes 5 factorials over 2 factorials, 5 minus 2 factorials, cosine cube theta, I sine theta squared plus 5 factorials, this 3 factorials, 5 minus 3 is 2 factorials, cosine squared theta, I sine theta, power 3, okay, and then plus, now this one, 5 factorials over 4 factorials, and 5 minus 4, 1 factorials, cosine theta, I sine theta over 4 plus 5 factorials over 5 factorials, 0 factorials, I sine theta power 5. And it is 1 because cosine 5 factorials by it, so it becomes cosine power 5 theta plus this is 5 over this is 4, so it means 5 4 factorials, 4 factorials, cosine of 4 theta, I sine theta. Now this one, 5 times 4 times 3 factorials, 2 factorials, and times 3 factorials, divided, this divided as well, later. Cosine cube factorials, and this is I squared is minus 1 minus sine theta plus 5 factorials, 5 times 4 times 3 factorials over 3 factorials, 5 minus 3, yeah, 2 times 2 cos squared theta. This is minus I sine theta, sine cube. This is square. Yeah. Sorry, not this one. Yeah, this one. Okay. After that, this one is part 5 times 4 factorials over 4 factorials times 1 cosine theta. This is I power 4 is positive 1. So this is sine theta power 4. And then plus this is 1 I sine of 5 theta, because I power 4 is positive 1. So becomes cosine power 5 theta plus 5i cosine power 4 theta sine theta minus 10 cosine cube theta sine squared theta minus 10 10i cosine squared theta sine cube theta plus 5 cosine power 4 theta sine cosine theta. This one. Wait. This because 5 cosine theta. This one. 5 cosine theta sine power 4 theta plus sine power 5 theta I. So after that, in A plus BI, so it will be cosine power 4 5 cosine power 5 theta minus this one 10 cosine cube theta sine squared theta, and then which one? This plus 5 cosine theta sine power 4 theta sine power 4 theta, and then plus 5 cosine power 4 theta sine theta minus 10 cosine squared theta sine cube theta plus sine power 5 theta I. Okay. This is the solution for 12a. Next, 12b. By using the Moivre's theorem and your answer to part A, show that sine 5 theta equivalent with 16 sine power 5 theta minus 20 sine cube theta plus sine theta. Okay. Now, that would be cosine theta plus I sine theta power 5 equals, wait, sorry, equals cosine 5 theta plus sine 5 theta I here. Okay. Now, for the imaginary part at A, this imaginary parts. One. So sine 5 theta equals 5 cosine of 4 theta sine theta minus 10 cosine squared theta sine cube theta plus sine of 5 theta. Now, if cosine squared theta equals 1 minus sine squared theta, so this equation being sine 5 theta being 5 times 1 minus sine squared theta squared sine theta minus 10 times 1 minus sine squared theta sine cube theta plus sine of 5 theta. Now I will expand this, becomes 1 minus 2 sine squared theta plus sine of 4 theta times sine theta minus 10 plus 10 sine squared theta times sine cube theta plus sine power 5 theta. After that, multiply 5 minus 10 sine squared theta plus 5 sine power 4 theta times sine theta minus 10 sine cube theta minus 10. Oh wait, this is this minus and minus. It means this is still minus. Supposed to be minus here, so it becomes plus. Right. Sine power power 5 theta sine power 5 theta. And the next step, 5 times sine theta minus 10 sine cube theta plus 5 sine power 5 theta minus 10 sine cube theta plus 10 sine power 5 theta plus sine power 5 theta. And the next is accumulate 16 sine 5 sine power 5 theta. After that, one or minus 20 sine cube theta and plus 5 sine theta. This. Now, see, show that theta equals pi over 5, as well theta 3 pi over 5 are solutions. So that pi over 5 and 3 pi over 5 are solutions of the equations when 16 sine power 4 pi, 16 sine power 4 theta minus 20 sine squared theta plus 5 equals 0. When this equals 0, okay, so let's see, 16 sine power 4 theta minus 20 sine power 2 theta plus 5 equals 0. So from B1, the sine 5 theta equals 16 sine power 5 theta minus 20 sine sine cube here. Factorize sine theta. 20 sine squared theta plus 5 based on this information that this is 0. So sine 5 theta equals 0 because 0 times sine theta. Now sine pi equals theta, sine pi equals 0, sine 3 pi, sine 3 pi as well equals 0. So based on this information that it means 5 theta equals pi, so theta equals pi fifth, and 5 theta equals 3 pi, so theta equals 3/5 pi. So proof. Next, D. And D, double I. Show that sine pi fifth times sine 3 pi fifth equals square root 5 over 4. Okay. This is I, the next double I. I will begin with this equation that 16 sine power 4 theta minus 20 sine squared theta plus 5 equals 0. Now, if A equals sine squared theta, this equation being 16 A squared minus 20A plus 5 equals 0. So we are going to find roots of A is 20 plus minus square root 400 minus 4 times 5 times 16 over 2 times 16. So it becomes 2400 minus 320. Okay, so it becomes 20 plus minus square root 80 over 32. 20 plus minus square root. This is 16 times 5. So 4 square root 5, 32. And next divided by 4, 5 plus and minus divided by 4, 8. Yeah. So it means sine squared theta. I recall that A equals sine squared theta. So sine squared theta or sine squared 3 pi fifth is 5 plus square root 5 over 8. So it is sine 3 pi fifth square root 5 square root 5 8. Another sine squared theta is sine squared pi fifth 5 minus square root 5 over 8. So sine pi fifth equals square root 5 minus 5 minus square root 5 over 8. And if sine pi fifth times sine 3 pi fifth, it becomes square root 5 minus square root 5 over 8 times 5 plus square root 5 over 8. And it becomes square root 25 minus 5 over 64. Becomes 20 over 64. If we divide by 4, becomes 5 over 16. Square root 5 over 4. This the solution. Okay, students, thank you for joining with me in this lesson. Later, if you have any questions, you may email me, or when uh, I am in the school, you may ask me about which question you haven't understand yet. Okay, thank you, students. See you.